Hello everyone, I am Shurosri Pal. I am a Prime Minister's Research Fellow, and today we are solving this question from GATE Examination 2019 from the paper Biochemistry, question number 18. And the question states, the C-terminal carboxyl group and the N-terminal amino group in amino acids have a dissociation constant pKa of 2.2 and 9.2 respectively. The pKa of the side chain carboxyl group in glutamic acid is 4.2 and side chain amino group in lysine is 10.2. The difference in isoelectric point or Pi of lysine and glutamic acid rounded off to two decimal places. So this is a numerical answer type question. For solving this question, we need to understand the titration of amino acids. For more information, you can visit the Centennial course Biochemistry, and its YouTube link is also provided. So the amino acids, what is their structure? The amino acids have one amino group and one carboxyl group. Both are attached to the alpha carbon, and they also have a side chain. Now, according to the side chain, the amino acids are varied, and these side chains of the amino acids, they can be either neutral or hydrophobic, or they can be polar. They can be also charged. So this charge can be positively charged or they can be negatively charged. So either basic or acidic. Now these amino acids, they have particular dissociation constants of this carboxyl group and the N-terminal amino group. Now, dissociation constant means the pH at which that particular group loses its proton. So, carboxyl group loses its proton at pH 2.2 and amino group loses its proton after pH 9.2. Now, it is given here that the pKa of the side chain carboxyl group in glutamic acid is 4.2 and side chain amino group in lysine is 10.2. So we have to first calculate the isoelectric points of these two amino acids, lysine and glutamic acid, and then we can calculate the difference between these two isoelectric points. Now, this pKa of the side chain of the carboxyl group in glutamic acid is 4.2. It is given the pKa values of the carboxyl group and amino group is also given. So now how do we calculate its Pi or isoelectric point? Now this is something we have discussed before, that with amino acids which have three pKa values, that is we can assign them as pK1, pK2 and pK3, or we can also assign them as pKa for the carboxyl group, the pKr, which is the side chain pKa value, and the pKa of the amino group. So, and in this condition where these amino acids have three pKa values, then how do we calculate its Pi? Because we know when amino acids have two pKa values, that is when the side chains are not ionizable. So there are only two pKa values corresponding to the carboxyl group and the amino group. Then the Pi value is an average of the two pKa values. But for these kind of amino acids where there are three pKa values, then what do we have to do to calculate the Pi? So we have to consider the charge on the amino acid. So we have to consider this particular region when the amino acid is changing from +1 charge to 0 to -1. So we have to consider this region in the titration curve, and then we have to calculate the pi from these two pK values. So the pK values that are responsible, suppose this is pK1 and this is pK2, the two pK values which are responsible for this change of charge on the amino acid, that is from +1 to 0 to -1. Those two pK values we have to consider, and the pi will be average of these two pK values. Okay, the other pKa value we are not considering for calculation of the isolectric point. Now, this is something we had discussed before. So now we will look at the titration curve of the two amino acids that are mentioned in the question, lysine and glutamic acid. Now, first of all, we are looking at the titration of glutamic acid. So here, in very low pH, we know that in a low pH, the amino acids are usually cationic. So in low pH, in this low pH condition, when the pH is lesser than 2, then all the groups are protonated. We can see the amino group, the carboxyl group, and side chain carboxyl group, all of them are protonated. So the net charge on this amino acid is +1. Okay, now when the carboxyl group, the alpha carboxyl group, first loses its proton at a pH greater than 2.2. So it has a pKa value of pKa of the carboxyl acid group, which is 2.2, right? 2.2. And then, so when the pH goes above 2.2, the carboxyl acid group loses its proton. So now, what is the net charge on the molecule? The carboxyl acid group is negative, but the amino group is positive. So therefore, the net charge on the molecule is 0. Next, what happens? Next, which group loses the proton? The next group to lose the proton is the side chain carboxyl group. This side chain carboxyl group. And we have discussed, uh, it is also mentioned in the question, that the side chain carboxyl group has a pKa value of 4.2 for glutamic acid. It is 4.2, right? So now, when this side chain carboxyl acid group, this COOH group, when it loses its proton, it becomes CO minus. So now, what is the net charge on this molecule? So there are two negative charges and one positive charge. So therefore, +1 -2, which means the net charge of this molecule is -1, right? And finally, um, at a very high pH, that is when the pH is greater than 9.2, the amino group, the alpha amino group, will also lose its proton. So that is the pKa of the amino group, and that value is 9.2. That is also given in the question. So then, what will be the charge on this molecule? The charge on this molecule will be -2, because now there are two negative charges on the molecule. So therefore, the net charge on this molecule will be -2. So we have mentioned that when calculating pi of this kind of amino acids, we will consider the charge change from +1 to 0 to -1. So what are the two pKa values that we consider here? The pKa of the carboxyl acid group and the pKr, or the pKa value of the side chain. And we will have to make an average of these two. Okay, so we can calculate the pi from here. The pi will be 2.2 plus 4.2 divided by 2, which will be 3.2. So that is the pi of glutamic acid. Now let's look at the other amino acid, which is the lysine. Now lysine, we know it is a basic amino acid, so it has a basic side chain. And This is the side chain of lysine. Now, at a very low pH, we know that amino acids are cationic. And what is the weak charge on the lysine molecule at a low pH? When pH is lesser than 2. So, when pH is lesser than 2, the COH group has its proton, so it is neutral. But the side chain amino group as well as the alpha amino group, both of these amino groups are positively charged. So the net charge on this molecule is +2 when the pH is lesser than 2. Now, we know that the pKa value of the carboxyl acid group is 2.2. So beyond pH 2.2, the carboxyl acid group first loses its proton. So now, what is the net charge on this molecule? So this is +1, this is +1, -1. So +1, +1, -1. So which is the net charge on this molecule will be +1. The next group to lose its proton will be the alpha amino group. So the alpha amino group will now lose its proton. At which pKa value? It is mentioned in the question that the pKa value of the amino group is 9.2. So when the alpha amino group loses its proton, then the net charge on this molecule will be 0. Why 0? Because these two positive and negative charges are neutralized. So the net charge on this molecule is 0. And the last group to lose its proton from the lysine molecule will be this side chain amino group, right? So that will be the last part of the molecule that will lose its proton. And uh, for the side chain, the pKa value or the pKr is given for lysine 10.2. Yes, the side chain amino group like in lysine value, its pKa value is 10.2. Right. So now, what is the net charge on this molecule? The net charge on this molecule is now -1. Now, for considering for calculating the pi value, we will have to consider from +1 to 0 to -1, and from +1 to 0 to -1 in this range, what are the two pKa values? The pKa of the amino group plus the pKr or the pKa of the side chain, and it will be an average of the two. So it will be 9.2 plus 10.2 divided by 2, which will be 9.7. Right? So the pi of lysine we have calculated, it is 9.7, and the pi of glutamic acid we have calculated it is 3.2. So now we can calculate the difference. The difference in the pi is 9.7 minus 3.2, which is 6.5. So that will be our answer, right? So we have calculated the pi of glutamic acid, and we have calculated the pi of lysine, and we have now calculated the difference between these two. And that is what is asked in the question. The difference in isoelectric point of lysine and glutamic acid rounded off to 2 decimal places. So it will be 6.50. Okay. Remember that we have to enter this 6.50 in your exam, right? So that is our answer, and thank you.